Akamai Technologies is the leading provider of cloud services for delivering, optimizing, and securing online content. Excellence in mathematics and innovation is at the heart of Akamai's mission, and the Akamai Foundation is pleased to promote mathematical excellence in the innovators of tomorrow by providing scholarships to the top students of the USA Mathematical Olympiad and supporting the Advantage Testing Foundation Math Prize for Girls. And we are deeply grateful to the Akamai Foundation for its very generous support of the Math Prize for Girls. Our next speaker, Kate Jenkins, is Chief Mapping Architect at Akamai Technologies. She helps design the software algorithms that determine the flow of traffic on Akamai's worldwide network. Her group's software directs nearly 3 trillion web interactions every day to servers in over 130 countries. Math has always been an important part of Kate's life. She competed nationally in MathCount's math competitions, took advanced math classes, and majored in mathematics at Stanford University. After Stanford, Kate worked as a computer game 3D graphics programmer at LookingGlass Technologies, here in Cambridge, Massachusetts. She then went to Cornell University in pursuit of a PhD in applied math and left with a master's degree in computer science, an abiding interest in graph algorithms, and a dream job at Akamai. Kate enjoys sharing her passion for math and computer science with others. She was a driving influence behind Akamai's Girls Who Code summer immersion program, which just finished its 3rd summer bringing high school girls to Akamai for 7 weeks. She also co-created a How the Internet Works workshop run at the Eastern Massachusetts Girl Scouts STEM Expo, as well as here in Kresge Auditorium for 200 kids and parents as part of MIT's Science on Saturdays. Please welcome another member of the Math Tribe, Kate Jenkins.
Thank you, and good afternoon. I'm honored to speak to you today on behalf of Akamai and the Akamai Foundation. I'm proud to work for such a strong supporter of the Math Prize for Girls and excellence in mathematics. In the next few minutes, I'll talk about the role of math at Akamai and in my own work. I'll also tell you about some of the lessons I have learned through my career journey that I wish I had known when I was in high school. As some of you may know, Akamai was founded 20 years ago by MIT applied math professor Tom Layton and his grad student Danny Lewin. They developed mathematical algorithms to solve the worldwide wait, making the internet faster and more reliable by intelligently routing and replicating web content over a large network of distributed servers. Today, Akamai securely enables over $250 billion in annual e-commerce for our retail customers. We serve over 30 terabits per second of daily web traffic, and 85% of the world's internet users are within a single network hop of an Akamai CDN server. At the heart of Akamai is our mapping system, controlling the flow of traffic within our network of over 240,000 servers. At the heart of our mapping system is mathematics. We constantly evolve our algorithms as the internet evolves, supporting mobile users, TV quality video, the Internet of Things, thwarting massive denial of service attacks. We are solving an enormous, time-sensitive, highly dynamic optimization problem with evolving objectives. And if we mess up badly, we melt the internet. So no pressure. My background in math has opened doors for me throughout my career. It is partly why Michelle Gomans, who you just heard from, hired me into Akamai 17 years ago to work on mapping load balancing software. My current role as Chief Mapping Architect, in my current role, I'm responsible for providing technical vision and making sure that the different parts of our mapping system continue to work well together as we evolve to meet new challenges. I need to hold our complicated system in my mind, considering the possible consequences of design decisions and probing for weak spots and errors. I need the ability to sift through the noise and discern what is essential to our problem. These skills were honed by my training in math. When I was in high school, I had no idea that I would be where I am today. I was probably much like many of you. I liked math and excelled at it. I had participated in math competitions at the national level. Like perhaps some of you, I didn't know what I wanted to do with my life. I liked finding the right answers to problems, and I liked winning, perhaps more than was good for me. I wanted to be successful and pick the best career path for me, but the possibilities were overwhelming and the paths unclear. Memo to my teenage self: that's okay. You discover what is important to you in life by living it, by being willing to try something new based on what you've learned. Trust yourself and choose what feels right for you at the time, even if it is not what others expect. It's okay to be scared. Ask yourself, what would I do if I wasn't afraid? And then do it, even if you are afraid. The support of other math women is invaluable, and a strong foundation in math will serve you well, whatever path you choose. My own zigzaggy path goes something like this. I took part in a demanding university-level math program in high school. I stuck with it because the only other girl in the program became my best friend, and we wouldn't let each other quit. She's now a physics professor at Olin College, and we are still best friends. As a math major at Stanford, I discovered 3D computer graphics and loved how it combined linear algebra, logic, and art. I learned that I liked using my math brain to create things. I felt enormous pressure to go to math grad school and become a professor because so few women do. Saying no was really hard, but I eventually discerned that it is more important to live your own life imperfectly than to live someone else's life perfectly. It's okay to disappoint people if it means being true to yourself, and bravery can take many forms. I landed a job as a 3D game developer here in Cambridge after graduation, based on my strong math background and dubious coding skills. In my 3 years there, I learned that I love working together with smart, passionate people to build cool technology. I also learned that I want that technology to matter, and that games don't cut it for me. I also learned how to code for real. On to an applied math PhD program at Cornell University, where I finally discovered graph algorithms and how my favorite kinds of math, linear algebra, combinatorics, probability, can be used to create efficient algorithms that solve real-world problems and to prove that they work. There I learned about Akamai. I chose my own imperfect life again by leaving Cornell for my game designer fiance, my best friend, and a dream job at Akamai. So here I am. My work impacts millions of people every day. I use my math brain. I work with brilliant people to build cool technology that matters. I have amazing family and friends. I have a support network of math women within Akamai who keep me brave and care about outreach as much as I do. They gave me the confidence to step into my current position at Akamai. I had no idea that I would end up where I am when I was your age. How could I? The World Wide Web didn't even exist then. I didn't know what I wanted, but I ended up here today with a career that I love and is right for me. And what a place to be. Looking out at you, I see the faces of the most talented math girls in the country. Each of you is so much more than your test scores and accomplishments, impressive as they are. The potential in this room is staggering. Embrace your own unique journey. Work hard, be true to yourself, act fearlessly, support each other, and you will change the world in ways you cannot even imagine today. Thank you very much.